So we try to classify our climates, and then we work with them. So on a global, we need to understand it. That's a good reason to want to do this, okay? But locally, I need to understand local. So I need to understand my precipitation. At my site, what's the rainfall? I need a chart. I need to know when it's going to rain and how much it's going to rain so I can plan my agriculture. I need to know radiation because that's going to drive, we're going to see, our plants. We need to know the wind so we can put in wind breaks, wind mitigations. You should understand the different types of landscapes, topography of your site, any type of land masses. Are you near the coast, on a mountain? You can look at the altitude, and you can also look up the latitude of your site. So some key factors, topography. Are you on a mountainous slope? That's going to increase, for instance, your water drainage. Or you have any proximity to a coast? You could have problems with salting. Many trees are not adapted to salt spray from coast. So if I'm on a coast, I have to think more about salt than I would if I was inland. What about energy transfer? What about erosion? I built my house. How many people in California built their house on the edge of the sea and then it eroded and it falls in? It's not so bright. Is that something you want to do? And if we're going to have sea level rise, have you thought about your house is what above sea level? Anybody look that up? See if grandma's house doesn't exist if the sea level goes up by 2 meters. And what about any long-term seasonal changes that we may predict, especially with climate change? Global climate extremes are coming. What are we going to do? So look up your weather cycles in your area. It's very important to design to those extremes. So we can look at global pressure cells. This is how the Earth's atmosphere works. It works in spirals. So it's pretty cool, like permaculture into patterns. So each of these spirals has a high and a low pressure, and the Earth moves around in circles. They're counterclockwise, right, in 4 different interlocked spirals going around the Earth. And we have these that creates what we know as our polar jet and subtropical jets. So this is the air streams, and this is what stabilizes the temperatures. If these stop, remember as that ice melted and it stopped, that would actually create our climate to shift. So this is very important that they are stabilized. And we have the wind direction. So if we look at all the Earth's rotations, we have how the Earth is rotating, and it triggers giant eddies and cyclones around. So this movement of air in spiraling around the planet, that changing, right, in any way is what actually would change the environment, the changing of those pressure systems. So those wind directions, looking at it in a horizontal, the heat from the tropics. So what happens? The tropics is closer to the sun a little bit, but it's actually flat. So it has a perpendicular impact. So all of the sun's radiation hits the edge of the Earth, right? No deflection. It heats up the edge. The heat comes up, and then it gets to the atmosphere, and it falls back down. So the tropics heat up, and the falling heat hits into our mid-latitudes, and that's why we see the deserts and the mid-latitudes. So our wind streams, again, create vortexes, and we get hot and cold air streams. So dependent on where you live, we can see here, again, this normal year or an El Nino year, where the jet stream shifts slightly, and this place is getting cold or very hot. And so if you live in Chile, for instance, that would have a very big effect on their region and their ability to grow things. Wind directions can change things. So in 2012, they have the climatologists describe something called Europe's big freeze. Yeah? Like a little ice age. Temperatures all plummeted. What happened? That little jet stream moved south for that one time period, right? And almost froze Europe. But guess what? It moved back. But if it moves back and drops again and it stays, it would be almost inhabitable. So we have wind directions all throughout. So scientists are mostly modeling this. They're trying to have the models, and the computers are modeling the wind, trying to see how it moves. And this is what stabilizes, and we have an increase in temperature or a decrease in temperature, mostly about this. So different thresholds. Understand the temperature in your climate. Understand the water on your site, precipitation, and that needs to drive your soil type. So if I can work with my soils, I can store my water, right? And then I can understand my maximum or low temperatures. Then I can start to make informed design decisions that will be local. Global in context, understanding changing patterns of the world and possible extremes. And then local in understanding my particular site's needs. So the climate as related to permaculture, It's covered in basically 3 chapters, okay? So the major chapters are in the humid tropics, dryland strategies, and humid to cold. So Bill didn't try to do so many different ones. He just said it's either basically hot, wet, or cold. Let's look at it that way. So we'll cover these and how they relate to temperature, water, soil type, and future lectures. And we'll start with the next lecture basically moving into what's described as the humid tropics. So this is an overview we have. What is climate? It's kind of driven by these things. It's pretty complicated, unless you've probably gone to school for a long time. And even if you do then, I'm still not confident that how accurate they can predict things like solar flares, okay? But they can give us trends, and they can give us a warning to say, hey, it could easily get a lot hotter very soon. But it could also get cooler. Either way, as a designer, can you design to mitigate both an extreme temperature, right? So we can do that, and that's what we're going to look at. So now we'll go in and we're going to break it into dependent on where you're located.